Problem says the half-life of radioactive cobalt is 5.27 years. If 100 grams is present now, how much will be present in 20 years? So because we are dealing with a radioactive element, or because we're keen on the words half-life, we know the general formula is A of t, which that's the amount at time t, equals A naught, that's our starting or initial amount, e to the k, where this is going to be our rate of decay, times t. All right, now if we fill in the information that we're given, we're starting with 100 grams, so that is our A naught. In order to answer the problem, 20 years, that is my time, so I want to be able to just plug in 20 and evaluate. But before I can do that, I have to know what is my K. To find K, we use the other information we've been given, that the half-life is 5.27 years. Notice this is also a time, so I'm going to draw a line here because now we're working on finding K. 100 e to the k times 5.27. Half-life. We got to think about what that means. Half-life is the time needed for half of the substance to decay. So if we started with 100, after the half-life time, we're left with half of that, which is 50. Now we have an equation to solve for K. First step is divide out the coefficient. And then on the other side, I'm going to rewrite the order here with what we're more used to, 5.27K for the exponent. And of course, this simplifies to be 1/2. This is a shortcut you can use. Half-life, you don't even have to know the amount that you've started with. It'll just end up being 1/2 e to the half-life time times your constant K. And if you want to cut right to this formula, that's fine. You wouldn't even have to have the information on how much of the initial amount you have. But just make sure you don't confuse it with the equation where you do use the initial amount. Okay? But now to solve this, we need natural log of both sides to undo our exponential. And since our exponential has base e, it works out very nice that the right-hand side is just going to be the exponent, 5.27k. And now to solve for the k value, we divide. So we get the natural log of 1/2 divided by 5.27. Okay, that's the exact value for k. And if you can work with that and are comfortable with that, that's actually better. If you want to round, that's fine, but make sure you keep all of the decimal places your calculator says. A small rounding error here can make a huge difference in the overall answer. So I've got natural log of 1/2. Make sure you also put it in correctly. The 1/2 should be in parentheses. Divided by, and then the 5.27 should not be in parentheses. And we get that k is approximately, it's negative, I'm going to keep all my decimal places, 0.1315269792. If your k value is small enough, the calculator may use scientific notation, so watch for that. Remember, that would be an e followed by a number, so that would mean times 10 to the whatever power is listed after your e. So now if I take that and put it back into the equation, my overall equation is now, with my starting of 100, e to the, this number, times k, or sorry, times t, that is my k value. And now I can answer my question. 20 years, all I need to do is put in 20 for the time. Okay, now let me show you something else with the calculator. Because I had just approximated this exponent, I can use that to my advantage to where I don't have to retype this in. So I want 100 e to the, now mine puts it up in the exponent where I can see it, so I know the order of operations is going to be accurate. In general though, you might want to include parentheses, so I'm going to go ahead and put them in there. And I need my k value times 20. I just typed out K at the previous response. So what you can do on your calculator is do second, and then the negative sign above it in blue, it says answer. So it's going to take this previous answer and plug it in for me so I don't have to type it, times 20. Hit enter, and I end up with approximately 7 point, doesn't say how far to round it, so we'll just do what seems natural. How about 7.204, and we are in grams. So that's how much will be left. Okay. All right, so now does that kind of seem reasonable? Approximately every 5 years, half of it is left. So after 5 years, there's going to be around 50 left. After another 5 years, from that 15, there would be half of 50 or 25 left. After another 5 years, and you keep on going, yeah, it does seem reasonable to have a little bit around 7 left for this overall answer.